It's 3 o'clock and I'd like to continue presenting the workshop Fair Data. As you all know, Fair Data is part of the open science movement, and it's about reusability, redistribution, reproduction of research. And it's from all kind of research output, research data, lab notes, and also research processes. It can be raw data, it can be analyzed data, it can be everything. Why is it so important? Well, all about the money. Most public funds want to have fair data in the end, to share the data you have found with public money. Then you have to make it public as well. This is the sign of the National Scientific Organization in Holland. It's a hardcore funder in the Netherlands, and these are their rules. There's also another reason. When you publish your data early and without a paywall, there is a faster knowledge development. We have seen it in COVID, because everyone published their COVID findings. We could also see much more how the disease did spread, how the disease worked. Your research is more visible, and because of the visibility of your research, yourself as a researcher are also visible. And it's also because everybody can use your data and doesn't have to pay for it. There are also more opportunities for researchers who are not allied to a university to have their own analysis with the data. Patients' organizations are very don't have very much money, and they like to have the articles as well as the data to work it out for themselves. Also, UNESCO has said something about open science. Everybody has the right to freedom of opinion and expression. Well, it's also about information and ideas from any media, and data is also information. Also, they have to have the freedom to participate in cultural life, but also share in scientific advancement and its benefits. Data is also a scientific benefit. So, as United Nations stated, it's all about freedom, and freedom of data is also a part of the Fair Data movement. As you can see, the Sustainable Development Goals, yeah, I think some of us know them by heart. And one of the goals is to reduce inequality within and among countries. Now, you know, some of the countries have more money than others. So if data is open, can be used without paywalls, all countries have the benefit, and not only the rich countries. Also, educational students who don't have money have also access to the latest developments. And knowledge development is also a part of the scientific community. So it's all, yeah, it's good to have your data published. The European Code of Conduct, Anna mentioned it also. It has ethical guidelines, but they see also an infrastructure for the management and protection of data. And that's also for reproducibility, traceability, and accountability. You have to have your data well stored And also they say that research institutions has to reward open and reproducible practices. So this is when our organizations can take a part of it, to reward open and fair data. Well, as I said, open science is about reuse and redistribution, reproduction of research, and fair data is a part of it. I will show 4 themes: the findability of research, the accessibility of research, and the interoperability and the reusability of research. And that will be the 4 themes I will talk about. But first of all, I want to say what FAIR is not, because FAIR is not a standard. FAIR is based on principles with a goal to reuse. So you have to think about it yourselves. It's not that they say so and so you must publish. It's about thinking about how to publish as much as you think it's okay. Also, fair data is not always open, and open data is not always fair, because, as Anna already said, because of privacy problems, you cannot have all your data open. But you can have your data as open as possible if you anonymize these data. So then we call it fair. Fair is as open as possible, but closed if you need to. And also, that's also something about fair data. It's not only about human to be able to find and access the information. It's also about machines, computers, to find the data and not be interrupted by humans, therefore. I see some researchers who publish at ResearchGate and think they are publishing open. No, they're not publishing open, because a machine can't find, without interference of a human, these publications, because ResearchGate is closed for machines. Well, let's start with the findability. That is the first, the F is the first in the word fair. So we can see what it's all about. Well, I don't have to read it out loud, I think. It's also, it's about being findable. And you as a researcher have to check some of the things you have to do to make this findable. It says about a persistent identifier. It says something about metadata. And it says something about cataloging and data repositories. Well, I think for some of you these words are not familiar, so I think I can explain something about persistent identifiers, metadata, and data repositories. To begin with, the persistent identifier. Maybe you know already persistent identifiers. ISBN, the International Standard Book Number, the number the books have got, is an example of a persistent identifier. You see 978 is the number ISBN always have, with 3 other numbers as well. 81 is the number of the country the book is published. Then the next number, the field, is the publisher. And then you have the title and also a number to check if the number is correct. So this is how an ISBN is built upon. Well, another kind of number is the DOI. You see here a DOI, and you see here it's a DOI about the Journal of Tourism Futures. It's published in 2017. And if you ask the DOI and put it on the internet will know, oh, it's an article published by this authors with this title, and also if it's open access, you can have immediately all the information because it's open. Also, persons can have their persistent identifier. And maybe it's good to know why persistent identifiers are so important. And that's why you have an assignment right now. If you go to orchid.org, the website, try looking for a certain John Smith. I think you see more than one John Smith. And you see also, when you look at John Smith, there are several John Smiths who have published on all kinds of fields. And of course, you can also check your own name of that of your colleagues.
8,900. Almost 90,000 John Smith.
And maybe you can also, if you click on one of the John Smiths, maybe you recognize some persistent identifiers. For example, clicking on employment and show more detail. I will also go to the ORCID. I saw also there are a lot of John Smiths, as you can see. So it's good to have a certain number for John Smith and a certain number for John Smith who has went to the University of Ottawa and also has the University of York. This is the first John Smith in the row. And if you can see the employment, you can also have the organization identifiers. As you can see, the grid, for example, stands for, and now I have to read it because I don't have it already. The grid is a global research identifier database. It's all the research-based organizations have their own grid. Also, an ISNI is also an organization identifier, a persistent identifier. And it stands for International Standard Name Identifier. It's about an ORCID for creative persons, but also for creative industries. And scientific work is also a form of creative work. What you see is Wikidata. It's also a number, a ROR, Research Organization registration number, and even an URL. Some URLs are also persistent identifiers and others aren't. And the difference between them is they are persistent because of they will always have the same URL and there is always the same information in it. And if you see here, it's a grid with this number and you see all the information of the University of Ottawa. So you know exactly with which organization you have to deal. Also with the persistent identifier of John Smith, you know exactly with which John Smith you're dealing with. So this is the advantage of these numbers. You know exactly which person it is or organization it is and with which you have to deal. Another thing in findability is the metadata. Well, it's not the data yourself we are talking about, but it's the metadata. It's the data about the data. You see this. This is an example of a bird count in the Netherlands. And you see person A till D with a postal code and how many ducks were counted, how many doves, pigeons, is it, ostriches and penguins were counted. I'd like to put you to put in the chat which information we all want to have about this kind of data set, who should be readable for humans and machines before they counted this one. So which information is sufficient enough to be able to find this data and understand what the content of the data set is? Maybe you have got some ideas and maybe you can put it in the chat for me, please. What do we want to know about this data? It's quiet on the other side. Well, how about when the information is counted? So a year?
Date of collection.
Date of collection, I hear somewhere. Maybe you can fill it in the chat. Oh, date of collection. Yes, it's perfect. Perfect. Context. Yes. See about what's the description of the data, where it was collected. Yeah, you see postal code, but it's in the Netherlands. Yes. Any validation? Well, that's also something about the source, for example. Reliability. That you can also put in a README file. And reliability has something to do with coverage also. How it was collected, perfect, perfect. Method of collection, yes, for sure. This can all be described in the metadata. You have a title, creator, description, the date, the type of date is also one you can describe, which format you use, the language. This is in English, but it could also be in Danish or in Finnish or in Hungarian. So this is all the type of information. Yeah, it's about data. It's the information about the data. So this is what they mean with the metadata. To be continued, and my computer is stuck again. So sorry. Well, I have to leave it out again, and then I'll try to come in again with the sharing. Oh, they don't want to do it. And share again. I think the computer already wanted to have a break, but we're not there yet. Nope. Then, also about metadata, we did have said something about what it is, but also metadata are standardized, are structured, are machine and human readable, and they are a subset of documentation. For example, a README file. When you see this, and Ali will put the data set in a chat, look at the data and especially the metadata in this data set. You see that the researcher informed has first put an overview in it. You can see how the data set is cited. You see also that the data set has a DOI. It's the https doi.org and then the DOI. It is a persistent identifier. So the data has an assisted identifier. When you go to the description, you can see again the persistent identifier, but also you can see if there are descriptive metadata, if there is a link to the related data, metadata, if there is something said about file formats, and also about user licenses, when the metadata can be used or not. See for yourself, and I will look with you. I go to the description, and you'll see that there are also ORCIDs for the authors. Data created. You see also when the data is created. But I think what I like is here, the relation between the data. If I put on this, you see that this data is related to a peer review, an article about learning and teaching. And these are the authors of the article. And these are the data accompanied by this. You see also format files and a license. These licenses, Hamk told already also about Creative Commons licenses. It's about where people can use, and you see also there is unrestricted access and everybody can use the data if they share alike. I continue to explore this further in another by another team about reusability. So this is something about metadata. As we continue, was also something said about data repositories. And what is a data repository? Well, it's a database. It's a large database used to store documents and publish all kinds of digital objects. And a data repository can be used to make data more discoverable and accessible. And depending on the discipline, there are several kinds of these kind of databases, these type of databases. You have domain-specific databases. Well, for example, well, the CHESDA archives. It's social sciences. And what I like about the social science archives is that per country, there are several of them. In Finland, it's the Finnish Social Science Data Archive. In the Netherlands, it's the Data Archiving Network Services, DANS easy. In Ireland, there is something. In Austria, there's something. In Hungary, and also in Portugal, you have the Portuguese Social Information Archive. Thus the CHESDA archives are connected with each other. And the data set you saw before was one of DANS. Our researchers can publish in DANS for their social research. There are also institutional repositories and national repositories. I know the Portuguese will publish in their national repository. If you can't publish in a domain-specific institutional or national repository, you can also publish in Zenodo or Figshare. Zenodo is a cross-discipline repository. It's all. And you can put all kinds of data in it. Also, you can also publish articles in it. If you search for fair data, there are all kinds of documents about fair data. This is also the repository where our national organizations publish the articles about fair data. Figshare is another one. Which one do you have to choose when you're putting your data? You want to share your data? Well, first look at your organization policy. At NHS Stenden, we do not have an organization policy already, but we advise people to put their data in DANS easy, if they are social, and put their technical data at a repository organized by the 4 technical universities in Holland. Another part is to look if their data, this repository has a core trusted seal. And again, you see Zenodo. And that is what makes a data repository trustworthy. You see also, well, I don't see anything, no. But what you see is that they want to know how the author is appraised, if there is a digital object identifier, what is the digital preservation, what is the access right information, etc., etc., etc. If you have all these kind of things in under control, then you can have a core trust seal. It's a big thing. It's about something like an accreditation of the university. It's an accreditation of the repository. Now, you know all how much work it is. It's also much work to have a core trust seal. It's also, if you have to put your data set somewhere, or the metadata of your data set, if it's privacy, is it privacy concerned, or is the national security involved, then you also publish not your data set, but you can publish your metadata. Look at what the repository wants from you and if you can apply to this repository. And do they have clear terms and conditions about it? And also, I know from DANS and for you, the repositories we advise, that there are no costs before a certain amount of bytes. So this is something you have to keep in mind also. Well, assignment. How you look for a repository. If you put in, and it's already in the chat, I think, if you look at retreedata.org, you have a lot of repositories in a database. It's about 15,000, I think. And you can get a look at the repositories mentioned in your country. Or if you don't want to look at your country, you can also put on your research field. Then, if you look at the corner in the right above, then you can see already with the green and the orange and the all that kind of squares, you can see if they provide DOI and if it's certified. And if you click on the data on the repository's name, you can have more information about it. So I think you can play with it and look at it for a couple of minutes. So I hope you got a repository who you are thinking of as a good one. Do you have any questions about findability so far? Are there good questions in the chat? No, there aren't any? Well, then I would like to go further to the accessibility. Accessibility, what do we mean about that? Well, it's about giving access to your data. It's about following the persistent identifier, as I saw, as I already showed you. The persistent identifier, if you put them in the search query of Google, you can get all the associated data and metadata. It's also a protocol that you have the standard HTTP or HTTPS. So you don't have to go to the dark web to finally find your data set you want to reach. The access procedures includes authentication and authorization. Well, that's something more difficult, so that's something I want to talk about more. And metadata, we already discussed the metadata are accessible, even if the data aren't. So again, the privacy concept, the security concept, if you can't share your data open, you can share your metadata. It's still fair data then. About the access procedure, about the categories in accesses. Open access, it's all about receiving the access completely, having all the data in it. Restricted access, well, this is something about lifelines. It's research in the northern of the Netherlands where people can get a checkup, a health checkup with all kinds of measurements, blood pressure, but also blood controlled in the lab and all kinds of things. And it's about 5 years. Everybody gets their health check again, but you have a free health check. What is free? And the data they're collecting, they come in a great database. So it's a very, very nice place for researchers to see how illnesses perform, how health performs, etc. Well, this is something about the access in the data set. Well, researchers have to have an application form. Then it's presented open. You can see it. You see what people want to do, and also University of Para. It's not in the Netherlands. Beijing, Düsseldorf want to have access. Well, it's not that when you apply, I want to have access, that people automatically get access. They are finally, there's a commission who bows over it. If it's already research, you can have, you are followed by the article, but also you can get bits of the data set you want. You cannot go into the whole data set. You can only have the data set for the data collected that are collected that is good for your research. So this is a perfect example for restricted access. Not everybody has access, and there is a procedure to get the access. Also, Finland told about embargo. You can have an embargo on your set, and closed access is no access at all. It's closed. When you closed access, you have all. When privacy is involved with when intellectual property is involved, if national security is involved, there are much examples of closed access. So this is the kind of categories you can talk about. Well, let's have a break. But before we have a break, I want to know if there are any questions. Okay, then I want to share something with you. The people who don't want to have a break, I've got a t-shirt. May the open source be with you, and you can win it. So you can also...
I like it. I want it.
Oh, okay, well, then you don't have a break. Then you can see, this is the question. Well, I have to share my data. You already knew, it's something about the presentation again, sorry. You saw the counting of the different birds. And these different birds, that was not a counting with, I thought about it well. And I thought about it well, and there's a reason there are so many penguins involved and there are so many pigeons involved. And if you can mail the relation between the amount of penguins and the amount of pigeons, doves, I'll send you, not this t-shirt, this is mine, but I'll send you a t-shirt to your address. And I will look at it now. So see if you can see the relationship between the many doves, many pigeons counting, and many penguins counted, and the postal codes in the Netherlands. And then the other ones who don't want to have the t-shirt, well, they can have a 5-minute break. It's now for 50, 20, 42. Well, we see each other at 5:15, 48 then.